Okay, just doing out a few trigonometry questions that we were just having a look at, just because, you know, this is relevant for more so for what people are doing this week. Obviously, if this is going to be up, people are going to use it. They can use it forever, whatever. But like, yeah, it's trigonometry stuff we were looking at. And I just thought it was important for the current people. So basically, all your trigonometry stuff. Don't forget 13, 14, 15, 16, the log tables. Basically, there might be the odd thing that I'll refer to outside of that, but like that's where the majority of the stuff is going to be. I should also highlight this is only for honor level stuff. None of this is ordinary level. I don't think. I don't think any of this is ordinary level. So, I guess don't pay attention if you're ordinary level, or do if you want. I don't mind. But in honors, just remember that if you end up with a sine, a cos, or a tan of an angle is equal to a number, it becomes one of the cast system questions. And that is in this order, A, S, T, C, whatever way you want to remember it. Okay, I don't really mind, as long as you remember that's quadrant 1, quadrant 2, quadrant 3, quadrant 4, because we describe this to be 0 degrees and go counterclockwise always, no matter where the line is. Even if the line was here, you'd still go all the way around here. And it might be, instead of saying going like 3 degrees down, you'd say, oh, we go 357 degrees the other way around. It's just the way we're going to do it, right? So whenever you see one of these questions, they will always kind of give, well, no, they won't always. In all of these, I'll explain in a minute what I mean by that. In all of these questions, they give a bounds where they kind of say sine of x is equal to a half. What must x be? And they only want you to give answers in between 0 and 360, because technically there's an infinite number of answers that can go in here. But obviously they don't want an infinite number of answers. They only want all of the answers in between 0 and 360. So we're going to go about it. So what we would do is we do our little thing here. We say ASTC. It's a sine or sin. I'm going to, again, fluctuate my pronunciation of that. It's a positive a half. So we need to say what quadrants is sine positive in. And we'd say, well, they're all positive in A. And then this must obviously be positive in sine as well. We get our reference angle by doing the inverse of whatever the trigonometric function is, in this case sin or sine, of a half, and that is 30. So that is what we call our reference angle. And what that means is we'd have to go 30 degrees in the two quadrants we labeled, but you always have to go 30 degrees from the horizontal. We never interact with the vertical for these, right? Always the horizontal. Go 30 degrees from the horizontal. And then if you remember the rules, I didn't really write them in up here, but I guess I'll do it now. If you remember the rules here, theta is equal to the reference angle. I'm going to use alpha for the reference angle if that's okay, just quicker to write. Here theta is 180 minus alpha, or the reference angle. Here theta is 180 plus. And then here it is 360 minus. All of this I have in the actual trigonometry video. If there's something I haven't really explained, go look at the trigonometry one, and I'll be in there, I guess. So because the two quadrants we picked were A and S, and those are the two rules up there, we know that two of our potential answers are 30, and it would end up being 150 if you do 180 minus 30. You do also, though, don't forget, need to write in 360n. If you're using radians, do 2 pi n. I suppose I should real quick mention that when I said there was an infinite number of answers that can go in place of x, it's because I know the answers here are going to be 30. 30 works. Now, not all of the answers, but just to give you an example of how it's infinite, 30 works, but so would 390, and so would 750, and then so would 1010, and then so would 1370, I think. And the trick is that basically what you're doing is you're adding on 360 each time. And as long as you keep adding on 360 degrees, there's 30 degrees. If I go 360 degrees from there, you'll notice I go exactly back to where we started. And the calculation doesn't actually care how many times you've whipped around the circle. It just cares that we're at this line. It does not care. You could go around and 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 go back to the line. It does not matter, because we're just at the line, right? So it does not matter. So that's why there's an infinite number of answers. You could just keep adding on 360 till the end of time, and it would still work. And that's why they said, okay, only give us the answers between 0 and 360, because otherwise you'd have to give an infinite list. Sometimes, and I did say they'll always give you this at the start, and I kind of called myself up and I said, explain it later. Here's me explaining it. Sometimes they'll say, give the general solution form, or give it the general answer whatever. They'll use the word general. And it just means you would stop here, because what you're saying is all of the answers are going to be 30 plus some amount of 360s that we haven't like clarified of any specific number. We're just saying you could keep adding on. The 360n means you could add on any amount of 360s you want. Sub in any number for n there and you're good to go. And then this also is true, right? Because of the way the cast works, because of the A and the S. So it could be 150 plus any amount of 360s in that scenario as well. So those are general. If they ask you for general form or general answers or general whatever solutions, that's what these would be. Because you're not specifying a value for n, you're just kind of saying they all look like this. Now, if I was to start, and this is how you'd like to continue on, you don't really need this for this question. I was just kind of warning you for that might be an alternative version of the question that didn't come up in the list of questions I gave. But to finish this question off, right, again, you don't need to mention that's general form, but in this question, if you're to finish it off, we would start by subbing in n equals 0. And then you would say, oh, x is equal to 30 plus 360 times 0. I'm going to do it out properly, I think, this time, but I won't. I'll probably skip a few things when I'm doing all the other ones, because I probably will just do all of them just to be safe. But I don't want to spend ages doing like this plus 0 or plus 360 times 0 when we all know that's just, well, maybe I'm jumping the gun again, but you'll be able to do it. Hopefully you'll be able to tell from this one what I'm doing in the next ones, just to make sure that you're right. 30 and 150 are both in between 0 and 360, so they're fine. If we did 1, I would implore you guys not to really skip things in the exam, I suppose, because you guys might not know what stuff is important and what's not important, you know. Oh, but look, 30 and 150 were fine, but 390 is not okay because it does not fit in the bounds in the question. So therefore you just kind of stop. You say, my two answers are 30 and 150. Again, there's an infinite number of solutions. 390 is one of them, but it doesn't fit in between the 0 and 360 limits that they placed. That's that one done. That one's kind of easy because there's no number in front of the x, there's no number in front of the sign. There's not a minus on this, which also wasn't in the list of question, I think, so I will talk about that at the end. Yeah, I'll run through a few of these so that we're comfortable with them. Okay, so we're gonna have a go at this one then. So again, it's I will be skipping things. I can't remember what I said. I had a bit of a cut there, so I don't know I can't remember what I said most recent. I'm sorry. I might be repeating myself, but I'm going to skip a few things here because it's a very similar question. You'll notice all that's changed is really the cost. Now the 2 has changed, and I will talk about that one because that one is a bit important, but there's only one step in there that's going to change things. Again, ASTC, because it's a cost this time, we want to know where it's positive for costs, and that is going to be in A and C, because A again means all of them, C means costs. We're going to get our reference angle by doing cos inverse of a half, and this time that would be 60. Then what we're going to do is we're going to say 60 in both of those quadrants then would be 60 for the first one using our rule from before, depending on what quadrant we're in. And it would be 300 then, because the rule for here was the angle is 360 minus whatever the reference angle is. Again, we're always coming from the horizontal, so you're always going to use those rules that I wrote down. Now, the difference here is obviously it's 2x is equal to the 60 and 2x is equal to the 300, because what we're saying is the thing that can go in place of the 2x here, like for example, we can put a 60 here and cos of 60 would be a half, or we could put a 300 here and cost would be a half, right? So if the 60 or 300 goes in that place, that means they're in place of the 2x that was there originally. So the 2x is equal to 60 or the 2x is equal to 300. It's basically always this angle is equal to the two numbers at this point. Don't forget your 360n in both scenarios. Again, if you're doing radians, 2 pi instead of 360. Now the thing is, you always want to get x on its own. So what would you have to do here to get x on its own? Divide by 2. So you divide all of these guys by 2. We're going to see that changes up ever so slightly in the other ones. So we'd end up with x is equal to 30 plus 180n. And x is equal to 150 plus 180n. I'm always conscious that I might be making like numerical slips somewhere. If there is a mistake, let me know. But I think hopefully you are all grown enough to be able to be like, I know that's a mistake, I'll just fix it myself rather than make Graham's life even more miserable. So, yeah, so these are, again, our general solutions, like I was talking about before, where if they just said, what do all of the answers look like, it would be this. And instead of the 360n, it'd be 180n, just because we have to divide by 2. That's all. It's nothing too major. But this asks for specific solutions in between 0 and 360. So we sub in the 0 and the like, and again, I'm going to kind of skip a few if that's alright. I'm not going to write in the 180 times 0 if that's alright, because I think we all know that that's how it would turn out. Now, those are two numbers that are in between 0 and 360, so they're fine. Now I'm going to sub in n equals 1. And last time we ran into a problem, but here, and I will write it out because it is different, I suppose. Here, you'll notice we're just adding on 180 once, as opposed to 360 once, or 180 twice. So it's actually fine, because this would be 210, which is also still in the bounds of 0 to 360, so it's fine. Here we have 150 plus 180 times 1, which would be 330, which again is in between 0 and 360, so it's good. Now if we did n equals 2, it's where things get problematic, because you'll notice that we get x is equal to 30 plus 180 times 2, but 180 times 2 is 360. So again, we're adding on 360 to 30, which will take us out of the 0 to 360 bounds. Again, do it out if you're unsure. You get 390 and then go, oh, nope. So we have 4 answers this time: 30, 150, 210, and 330. In the last one, we had 2 answers of 30 and 150. Yeah, it's quirky that the 30 and the 150 show up in both, and it kind of scared me there for a second, but I think we're fine. I think the 2x is what just changed that around ever so slightly, but that's okay. Hopefully, again, hopefully I haven't made any errors in this, because if I've made errors, you guys are fucked. The green one, yeah, so this one is slightly different in 2 ways, and this is more reflective of what they've done in the past couple of years in the Leave Insert. It changes the bounds from 0 to 360. They've like nearly always been 0 to 360, and then one of the years they did this kind of nonsense. Also, sometimes they might write it in terms of pi, so instead of saying 0 to 360, they might say 0 to 2 pi, but it's the same logic. You translate to degrees and just do the same question as we've been doing, because the answer doesn't need, well, it depends, I suppose. Normally in trigonometry, they give you full marks regardless of whether that you put your answer in degrees or radians. But if they're very specific about it, try do it in whatever way they say. If let's say, for example, they did like say, oh, 100% I need this in radians, or else you get 0 marks, and you're crapping yourself because you don't know how to do radians. What you do is just do the question in degrees. You'd lose 1 mark maybe at most at the end for doing it. But even if at the very end you just said, well, my answer is 30 degrees, I will change that to pi over 6 radians, you still get full marks then, because you've given the answer in radians. I'm pretty sure that's how it works. Yeah, I can't see why it wouldn't. But I think you're pretty safe either way, is what I'm saying. But if you want to play it 100% safe, at the very end, change it. No matter if you, I would imagine most people are most comfortable with degrees. They ask for radians, change it to just radians at the very end when you have the final answer in degrees normal. So that's the 0 to, or the minus 180 to 180. We're going to see how that kind of plays out later on. The theta minus 20, it's kind of common sense when you do it, but the problem is, again, nearly always it had been like this, where it was 2x or 3x or 4x, and you just divide it by that number, like the way we divided with the 2. Here, it's ever so slightly different due to the fact that it's theta minus 20. All we're going to do, though, when we get to this step, instead of dividing both sides by 2, we're going to plus 20 on the other side. Like, it's maths that you guys have all been doing for years, so you'll be fine with it. Tan, again, is positive, so that's there and there. Happy days. We get our reference angle by doing tan inverse of root 3. Tan inverse of root 3, I should know, but look. Tan inverse of root 3 is 60 also. I promise I thought that's what it was. So that's our reference angle. That means that our answers, and again, in the same way that we put x equals 2 and 2x equals 2 and before, we put the angle, or the argument, they might use that fancy word instead of angle, you put that equal to 60 because it's in the first quadrant, and you put it equal to what would that be, 240, because that's what it would be in the third quadrant, because it would be 180 plus 60 if you follow my rules that I did at the very start on the quadrant that I drew at the beginning. it would be 180 plus whatever the reference angle is, and 180 plus 60 is 240. Again, you have to put in the 360M. Now the difference here is, again, you want to, like, you know, I would add 20 to both sides. Some people would just move the 20 and make it a plus, whatever floats your boat. But you'd end up with theta is equal to 80 plus 360m, because don't forget, when you bring the plus 20 across, you can only add like terms, so the 360n does not get involved at all. This would be 260 plus 360n. And then we do the whole shenanigans of n equals 0. Now, this one is super trippy because, and this happened to them in one of the years. This just came up out of nowhere, and I'll do it out because of how weird it is. If you sub in 0, your first answer for theta is 80, which is perfectly fine. However, weirdly, if you do it over here, you get 260 plus 0. And that's going to not be fine because 260 is not in our original bounds in the question. 260 is not in between minus 180 and 180. So it was weird for them because they kind of went, oh, 80 is 1, but 260 isn't. And it was very strange for everyone because normally every pair worked beforehand. It's incredibly rare that they were just like, oh, one of these numbers works and one doesn't. So that kind of messed people up. I don't know really how to explain this to you, but what this means is we wouldn't do n equals 1. We'd actually have to do n equals minus 1 to go backwards. The logic that I would use is, because of the 0 before, we never had to delve backwards, if you know what I mean. The fact that this went into minuses means we actually had to put it into reverse ever so slightly and just kind of go backwards. I'll do it out and we'll see now in a second if it makes more sense. So it'll be 80 plus 360 times 1. Minus 1, sorry. And if you do that, you get minus 280. But that's no bueno. We don't want that because that's not in the bounds. But over here, we'd have 260 plus 360 times minus 1. But then you'll notice that would be minus 100. And that is in the bounds. So that one is actually okay. Now, there's probably some logic here that somebody smarter than me could figure out, where they're kind of like, oh, well, it always has to be an even amount of answers, or you can tell based on this, but for me, it's just because I went into the minuses in the thing, you go into the minuses there. Otherwise, you just keep increasing the n until you get too high. You know what I mean? Like in the past ones where we went up to 390 and went, oh, I'm stopping now. Here, because it went minuses, we had to go backwards. That's my logic. There's one thing in the questions that I didn't mention, that didn't come up in any of the questions that I gave them, and I want to highlight it real quick. I won't do it a full question, but imagine if in the second question, in the red there, imagine it had been cos of 2x is equal to minus a half, and none of these kind of have accommodated that so far. But if it was cos of 2x is equal to minus a half, literally the only difference you do is at the very start, when you're choosing your quadrants, all you do is you say, when would cos be negative? So normally we would pick A and C for cos being positive, but because it's negative, we literally want the opposite versions, right? So we want those two because that's where cos would not be positive, i.e. where cos would be negative. Those are the two quadrants we would use, and after that, literally, we never touch the minus ever again. I can't stress that enough, right? So what we would do is we'd get the reference angle like normal, but we wouldn't do cos inverse of minus a half, we would just do cos inverse of a half, and that would be the 60 like before. So it's the same as up here, which might trip people up, but because of the different quadrants here, it would end up being 2x is equal to 120, and 2x is equal to 240, right? And the reason is because those are the rules for those quadrants, and you notice that's where it differs. So here it was 60 and 300, but here it's 120 and 240 because we picked the different quadrants. I cannot stress to you enough how it's literally the exact same kind of layout to the question. The minus never shows up ever again other than for these quadrants. You just ignore it. You never go near it. Hopefully you understand that. I know there's one or two of you fucks that are just going to try throw it in somewhere and be like, you never said, and then I'm going to have video evidence this time. So, yeah. Okay, just a couple more complicated ones, but again, it's not complicated in the sense that we're going to have to change anything that we've done. It's just that we're going to have to do an extra little bit at the start and then just carry on like normal, right? So we just kind of have to rephrase these questions because you'll notice These are different where here it was just sine or sin, here it was just cos, here it was just tan. There was nonsense in the angle part in the argument, but here there's all sorts of bullshit going on that we just don't have to deal with. So instead, what we're going to do is we're going to manipulate it first. We don't want the 4 in front of this guy. We just do not want him here. We need it to be cos or sine or tan of an angle is equal to a number. So what we would do is, how do you get rid of a 4 normally that's in front of if it was 4x, you would divide both sides by 4. So we're just going to do the same thing here. We're going to divide both sides by 4. We're going to end up with cos 2 theta is equal to 3/4. And then the question literally just becomes what we have just done. Oh, sine, cos, or tan of a number or of an angle is equal to a number. Cast system, ASTC. Cos is positive, so we're going to go here and here. We're going to get our inverse of 3/4. Now the problem is with these ones, I didn't choose these, right? But the problem is with these is they immediately go into decimals. I don't know if they were intended to be done with radians. But they're kind of gross, so will I do them? I don't think I will, because like I'll tell you what, I'll do cos inverse of 3/4. You can skip ahead to where I've actually started writing again if you want, but cos inverse of 3/4, yeah, 41.4. You know, I'll do it anyway. I'll do it. So we end up with 2 theta is equal to what did I just say? 41.4. Now that's it rounded, obviously. Now it'll be 41.4 for the first one because that's the first quadrant, and then the second one would be in the fourth quadrant, so it's going to be 360 minus that, so it's going to be 318.6, I think. You do the 360n, obviously, divide everything by 2 like we did before, so that the theta would be on its own, and then that was going to be 20.7 plus 180n, and that would be 159.3. Isn't it? Yeah. Plus 180n. That's a 1. That's a 1. And then you just do the nonsense of subbing in n equals 0. And you get your first one is theta is equal to 20.7. Theta is equal to 159.3. Yup. N equals 1. Because we haven't hit the boundary yet. We haven't hit 360 yet, so we're just going to keep going. That would be 200.7. Yeah, and then this one would be oh god, that's a 1, so that'd be 339.3 maybe. Again, that's just calculator stuff, so even if I fucked it up, don't worry about it. And then so those are 1, 2, 3, 4. Now I promise you, if I do one more, it will go over the boundary, because you'll notice I'll be doing theta is equal to 20.7 plus 180 times 2. 180 times 2 is 360. No matter what we add to 360, it'll be bigger than 360. I know, other than zeros and minuses, you're very clever, but we don't have those here, so yep. That's out of bounds. We don't like it. We don't want it. Those are our 4 answers for that one. I don't like the decimals. I don't think I've ever seen them do that in the actual exam, right? Again, here we just want tan of 4x is equal to something. We need to get rid of all the other things. So what we do is we get rid of the thing that's least attached to the tan first, as in make it like so. If you follow me, I move the minus 4 across, then divide both sides. Well, 5 plus 4 is 9. Divide both sides by 3 then. And you get 9 over 3, which is 3. And then you just go, oh, tan of an angle is equal to a number. Then I'm just going to do this. Tan is positive. I'm going to go here and here. I'm going to say 4. Or no, I'm not. I'm going to do tan inverse first. I forgot that step. I forgot to get my reference angle. How embarrassing, am I right? Tan inverse of 3. What the fuck? 71.6 if you round it. But that means that 4x is going to be equal to 71.6 again, because we're in the first quadrant, so happy days. And then 4x is equal to, in the third quadrant, it's going to be 180 plus, so that's going to be 251.6. You do 360n. I feel like my writing is getting messier, but it's just because I feel like this is irrelevant and I'm just trying to fly through it. Divide everything by 4, you get 17.9. yeah, plus 90n. Here you get x is equal to 62.9 plus 90n. If you divide everything by 4, I don't know if I said that, I just got lost in the sauce there for a bit. And then you just, now the weird thing is it said in between 0 and 90 here, so I don't know, we'll see how this goes. I'm just going to start by subbing in 0, see where it takes us. X is equal to 17.9, x is equal to 62.9. I imagine if we go any further, oh yeah, no, of course it would, because you'll notice if we do n equals 1, we'd be asked to do 17.9 plus 90 times 1, which is too big, because it'll be 107.9. We could tell it was too big because of the plus 90, and then if you add 90, it's going to go above 90, so we don't want it. So we only have those two as our answers, and there you go. That's that one done. So this one is one of those trigonometric identity ones, and I hate these ones because I feel like people put way too much stock into them, because there's a chance they just don't even come up. If they do come up, they'll be like a part B of a short question. They're not that big a deal, considering, like, okay, so if there was like 3 or 4 of them, I would say, oh yeah, just learn them off. But because there's like so many, there's no point learning them all off, because there's just no point. As I said, it might not come up, and even if it does, it's like 10 marks. Maybe it was 15 one time, but like, it's not that big a deal. Give it a good shot, give it an attempt by all means, but don't try do all of them. Don't try practice all of them. Don't learn them all off. You're much better off studying something else instead, like some other part of trigonometry, even, not even anything else. But you're basically going to need page 13, 14, and 15 for these. In some of the rarer cases, I will say, the trigonometric identities they ask you to prove are the sine rule and the cosine rule, for example, like things like these. They are fishy ones, and they literally don't come up that often, so I kind of am shaky on them as well, because they're also, in my opinion, the toughest ones, because you have to actually like do it from scratch, whereas the other ones are all kind of using trickery and mathematical nonsense and a bit of logic. The other ones are literally like, you have to use the unit circle and imagine it to be a triangle, and then pretend that you're doing this, and then split the triangle in half and do all sorts of nonsense. Those ones are actual proofs that I probably should just do in a video and put them up. But as I'm just saying, the entire trigonometric identities thing gets way too much effort for the amount of marks you're going to get, in my opinion. So I'm going to do these questions out. Go to my trigonometry video if you want to actually know for certain how to do this stuff. Well, not for certain, but like, again, me going through it fully without just being miserable about it. Yeah, my main things are, and before we get into it, I want to highlight tan squared theta, because or x here, sorry. Tan squared x is the same as tan x squared, but that is not the same as tan x squared. You see how those two things are different, but they're pronounced the same. If I said tan x squared, that technically could be applied to both of them. So that's why we never really write this one in practice. We always write it this way, because that's tan squared x. So then if anyone says tan x squared, it's implied you're doing this one down here. But for us, for the purpose of this, I will very often rewrite it like this, just because you guys aren't going to be doing maths all the long day. You don't really care for that. So I'll break it down to a simpler way that you'll be more used to seeing. Yeah, so that's just an aside. That's just in all trigonometry. I just haven't mentioned that yet. I was going to mention it at some point, I'm sure. Now for the identities, right? For the identities, there's like a couple of things we can take into account. Gives us a leg up, I suppose. Don't forget, you get a lot of marks just for attempting things. You don't need to get it 100% right to get it. It's not like the old days where it's like 0, you get 0 or you get 100% of this. Give it a shot, you'll get some. Generally, the rule is we're going to fuck around with the left-hand side of the equals and turn it into the right-hand side. Anything that's not a sine or a cos, use page 13 of your log tables here. I don't know if you can see my cursor without me writing, actually. That will kind of tell you how to translate everything into sine or cos. If the angles don't match, you want to kind of figure out a way to get them to match. That's kind of like, I know that's vague and doesn't help you too much, but it's just kind of like the angles don't match. I will try find a formula on page 14 or 15 that combines the two angles together or separates it out or does something like that. And also, this guy here is like a big deal on page 13. Cos squared plus sine squared equals 1. It sounds a bit weird, like it doesn't sound too helpful, but you notice you could rearrange it. For example, if you bring the sine squared, or if you bring the cos squared to the other side, you'd end up with sine squared is the same as 1 minus cos squared, or vice versa, that cos squared is equal to 1 minus sine squared. They are very often used, so that's kind of handy to know. So my logic is we're going to mess around with the left hand side, we're going to make it into the right hand side. As I said though, anything that's not sine or cos, I always like to change it. Now this isn't going to be part of my question, this is like in a note for me. I don't put this in for them, this is for me. I'm going to say, oh well, that's the same as 2 tan x squared, just because I rewrote it using this notation, right? I just said tan squared would be the same as tan x squared. There's still a 2 chilling in front because there was a 2 chilling in front here. But if we look at page 13, it tells us tan is sine over cos. So that would be like 2 sine x over cos x in place of the tan. The 2 and the squared are still chilling. And that can be written in a couple of different ways. Like, for example, you could have 2. If you square a fraction, you have to square the top thing and square the bottom thing. That's supposed to be a c. So that's one way you could do it. Some people would also prefer to put the 2 on top of the fraction, but that's something I won't explain why that is here, because I'm getting too lost already. I'm not just actually doing the question. But basically, that red bit is me kind of saying that's what I want. Turning the left hand side into 2 tan squared x is asking a lot. By kind of translating the right hand side, we've given all sorts of different options. As long as we get the left hand side to look like one of those, we're fine. We'd have to actually write it out, but what I mean is we'll know ourselves. We kind of go, oh, that looks like the second red bit, so I'm on the right track, you know, or that looks like the fourth red bit, or that looks like whatever. It's kind of like giving you a net of things to fall into, rather than just you have to get 2 tan squared x. You can get any of them now, which is just in my mind a bit easier, a bit nicer. The tricks that we would normally use, it just kind of is maths, and I know that's kind of annoying to you guys, but here we have 2 fractions that are being minused. How do you minus 2 fractions? Well, if you're adding or subtracting 2 fractions, people do weird shit. They do the butterfly method, they do the arrows, they do cross, whatever the fucks. You all name it weird stuff, you all get it wrong all the time, I'm sick of it. Basically, the denominators have to match. So in the same way, I just want to highlight, if you had a half, what you could do is you could triple the top number, and you could triple the bottom number, and you would end up getting 3 over 6. Which looks different from a half, but it's essentially the same number. They're both 0.5. They just look different. So if you multiply a fraction on the top and bottom by a number, all you're doing is changing how it looks. You're not changing how it actually is. So for example, now this is more so in algebra. I won't get to. I want to. I can feel I want to explain why. What I'm going to do is I'm going to multiply on top and bottom of this fraction by 1 plus sine x. And there's not going to be a lot of room for it. We're going to multiply on top and bottom here by 1 minus sine x. Again, multiplying on top and bottom of the same fraction by the same thing is fine, as we just saw. I know this is a mess. I apologize. It's fine, as we just saw. And the benefit is now, if I write out both of those properly now, you'd end up with 1 plus sine x multiplied by sine x over 1 plus sine x multiplied by 1 minus sine x. Now, I will warn you, when people do this very often, they get excited and they go, oh, these cancel. And they do cancel, but that's because we put them in to be the same in the first place. They are the same for a reason. We did that on purpose. So don't immediately cancel those out, or you just go back to where you start. I see that happen a lot. People are just very excited that they think they can make the maths easier, but we've deliberately weirdly made the maths harder here, because it's going to pay off in a split second. You just have to hang with me for a second. You'll notice the reason I picked those ones in particular, I basically picked for each fraction, I picked the denominator of the other fraction. So for the first guy, for this one, for sine x over 1 minus sine x, I picked 1 plus sine x in the green, because that was what was on the bottom of the other fraction. And then for the second fraction, I picked 1 minus sine x, because that's what was on the bottom of the first fraction. And by doing that, you'll notice that the bottoms match now. So what I can do is I can join them as one big fraction now, where basically I write the top of the left-hand fraction. The minus that was in between the 2 fractions goes in between the tops now, but the 2 tops go together on the big fraction with the minus in between them, if you can kind of follow what I'm saying when I say that. the denominator, you only need to write it out one time. Some people write it out two, and that's just not a choice, that's just incorrect, so don't do that. You'll notice that that's just what it turns into, a single fraction. It looks horrendous based on the question. I appreciate that. But I promise you it's for the best, because a single fraction is what we need. Because remember, we wanted to turn it into 2 tan squared x, or one of these red things. Having two fractions is just impossible to see. So having one fraction, I promise, is easier. We're going to multiply in the brackets. So like 1 by sine x is sine x. Sine x by sine x is sine squared x. I'm going to write it like this, if that's okay with you guys. Now, there's a minus here, so I'm going to just do big brackets. I'm going to multiply out these two lads, and I'm going to leave the minus outside, so I know I'll deal with that in a second. Sine x by 1 is sine x. Sine by minus sine is minus sine squared x. Still over the denominator, of course. It's a pain in the hole for me to write it out. I know, I'm sorry. One of this was giving out that I go too slow when I do this shit, but I don't think there's anything that's not necessary, so go fuck yourself, basically, to that one guy. He knows who he is. And if he doesn't, everyone else, you know, we'll all let him know. Don't worry, we'll tell him. But the minus in front of this thing now, I'll multiply it in, so it'll be minus sine x, and then minus by minus sine is plus sine squared. So I left the minus out there originally outside of the square brackets, because people always multiply, they say minus sine by 1, and they put the minus on this guy, but they'll always forget this guy also has to be minused. Always. They'll always forget that the sign we multiplied here, it's really a minus sign. They always forget that. Always. So that's why I think it's imperative to do that, because you'll notice that it's not actually a minus sign squared, it's a plus sign squared, because it was a minus by a minus. Everyone forgets that. Again, denominators, I try to do these fast, alright? There's just a lot involved. It's not fucking something easy subject like biology or some shit. You'll notice that sine x cancels with sine x, so that's nice. So on the top we're left with 2 sine squared x, because there's 2 sine squared x's. We never really want to multiply out the denominator until we get to the very end. So you'll notice that we got to here at the very bottom, right? Because I didn't multiply the denominator at all. So this is the fraction we have now. It's a single fraction. It's simplified. I will say, at a certain point, you might get to here and be like, well, fucking this is nonsense. I'm going to leave it. Which is fine. You did a lot of work. You get a lot of marks. But you'll notice the numerator is 2 sine x, or 2 sine squared x, which you'll notice is actually one of the guys up here. 2 sine squared x being on the top is kind of what we want. So we're on the right track. We just need to change the bottom. Now, the reason why I haven't changed the bottom yet is we generally leave it in the hopes that, someone's texted me. Not that important, I don't think. No offense. But we don't change the bottom till the very end in case when we had fixed the numerator, something cancelled. Now, nothing cancels, so we just have to like live with it and multiply out the denominator now, because it's not what we want and it doesn't help us. So I'm going to multiply out the bottom. 1 by 1 is 1. 1 by minus sine is minus sine. Sine by 1 is sine, minus sine by sine is minus sine squared x. Oh look, these guys cancel. Happy days. So we're left with 2 sine. Yeah, I'll write it out. I was considering just rubbing it out, but I just thought that would cause somebody to cry. 1 minus sine squared x on the bottom. So the numerator is fine. The 2 sine x is what we want, but if you remember up here, what we wanted on the bottom was a cos squared x. Oh no, we don't have that. We have 1 minus sine squared. But whoa, lo and behold, page 13 comes to our rescue. This is why page 13 is so cool. Cos squared is equal to 1 minus sine squared, you'll notice. 1 minus sine squared is what we have on the bottom of the fraction. So that means we can replace it with a cos squared on the bottom of the fraction. Happy days. Happy days indeed. So that we can get rid of that and just change it to a cos squared. I'm not writing out the fraction again. Fuck you guys. But then, because we basically got to here, we can just now go in reverse back all the way to 2 tan squared. And I'm kind of going to gloss over it ever so slightly, but basically what we can say is then just, like, literally just writing out what I wrote earlier. And that's the same as this. I'm just kind of going backwards through the red pen I set up at the very start, because then that would become this, and that becomes this. And we're done. we fucked around with the left-hand side till it became the right-hand side. Now, I understand these questions are very annoying when you see someone else do them and you're like, oh, I see every step you did is kind of okay. Like, the fraction bit is probably the hardest bit, I imagine, there. Replacing the 1 minus sine squared. I feel like you're all like, well, I could have done that one, but you didn't, so that's why you're here. I don't know what to tell you. Yeah, I know it's annoying because it seems so set. It's so clearly there's only one way of doing it when you've done it out. I get that, and at the start you were just floundering. When I first saw this one, I didn't know how to do it either. I just went, well, there's two fractions there. I want them to be one. So I just went, how do I make fractions join together? And I did my nonsense that I did there. You'll notice up until here, that's all I did. Up until, I don't know if you can see actually my cursor. I don't know if I've set it up that way. But basically up until, up until this fraction here, I didn't really bother my hole with anything other than just doing out the fraction. I just put two fractions together. Got to there, went, oh, nothing cancels, and the numerator is what I want, but the denominator isn't. But again, nothing cancels, so I'll just multiply it out. And I got 1 minus sine squared, and I went, oh fuck, I know that's cos squared. And then it matches with one of the guys over here. That's all. That's all it is with this. I say that's all, but I'm not trying to be dismissive about it. I just know these ones cause a lot of hassle. Again, don't stress about them too much. I'm going to do all these out, but don't people put too much effort into this. It might even be too long a part of the video I'm dedicating to this, but you can skip it. You can do by 2. You can do whatever. You know, you're a grown man at this point, I suppose. You're not a grown man. Previous Graham lied. So it's the same thing. Basically, like, you look at this and you go, oh shit, this is nonsense. But again, there's two fractions on the left. We're going to mess around with the left hand side, turn it into the right hand side. The difference here is, I suppose, there's no weirdness. They're all sine and cos, so I don't need to do any of the red pen like I did in the previous one. So I don't need to like maneuver it around and just see what's what. I just know it should equals 2 over cos x. There's different ways of writing that, but that's generally clear enough that we should, when we get to like our similar of what we got to at the other certain point in the question where we kind of went, oh, that's 2 sine squared x, we're on the right track. 2 over cos x is decent enough in my mind that when we get something here, we're going to be like, oh yeah, happy days. Now, I'm going to do the same shenanigans where each fraction gets multiplied by the denominator of the other fraction on top and bottom. Hopefully you're okay with that. Again, that's more algebra, so I won't go into it too much here. If you're going to be taught that, you should really be taught that using numbers rather than trigonometric ratios. But if I multiply this fraction on the left by cos x on top and bottom, we would end up with this. Yeah, I'm just going to kind of skip a line or two because hopefully I explained it well enough in the last one that you can, you know, over a minute or two kind of figure out what I'm doing. But then I'm going to multiply the top and bottom of this second fraction by 1 minus sine x because that was the denominator of the first fraction. So then I'm going to have, down here, I'm going to have this. And oh, would you look at that, the denominators match. Happy days, happy days. So I can just write it all out as one big fraction. The green is starting to mess with my eyes, I feel like. That's good. That's a good sign. 1 minus sine x. All of that is over 1 minus sine x. Again, I'm not going to multiply out the denominator just yet. I feel like well, I don't know. I was going to say I feel like we need to, but we won't know. Cos by cos is cos squared. Again, I'm writing it like that. Hopefully you're okay with that. Now, here's a plus this time. In the previous one, there was a minus here, so I did the square brackets to keep in mind for the minus. Because it's a plus, I don't give a shite. 1 by 1 is 1. 1 by minus sine is minus sine x. Sine x, minus sine x, sorry, by 1 is minus sine x. Minus sine x by minus sine x is plus sine squared x. All over this guy. Now, what's the dealio here? You'll notice, well, nothing cancels out. However, we have cos squared plus sine squared. And if you look at the top right of page 13, they told you that cos squared plus sine squared is equal to 1. So that means I can kind of like cancel them out and just put a plus 1 in its place, if you follow me. Now, I don't want that x there. I'm going to get confused by that. But the cos squared x here and the sine squared x here together combine to be 1. So I can just get rid of them. I was afraid to scribble it out in case you guys can't see it, but like, you can just rewind. You guys have the ability. Yeah, so if you get rid of them and put a 1 instead, technically I would have written out the whole fraction again a second time, but I just don't want to do that here because, again, it would take too long. Now, minus sine x is minus 2 sine x, right? It's the same as if it was minus, y minus y. You would say, oh, that's minus 2y. So here, because it's minus sine x, it's minus 2 sine x. It's going to be over 1 minus sine x cos x. Now, I can see it now. Yeah, okay. I was going to say I can see it. I'm not sure how to explain it. But there's a cos x on the bottom, and there's a cos x on the bottom. That's fine. There are 2's on the top, and we want the 2 on the top. So that looks fine, actually. We're on the right track. This guy, in my mind, is the biggest problem because he's nowhere to be seen. The sine x is a problem as well on top, but he's joined with the 2 that we kind of care about. So he's not that bad. The trick is, though, I don't really know how to explain this to you, but what we're going to do is we're going to factorize the top. We're going to take out what's common, because you'll notice then we'd have a single 2, which is what we want. We don't want 2 2's floating around. But it's super handy as well, because you'll notice if you factorize the 2 out of it, and this is the thing I don't think you'd see if you weren't as experienced in maths, like if you haven't been doing maths as long, because you'd be left with a 1 minus sine x on the top and the bottom, and they cancel it, and you're left with 2 over cos x, and you're done. So there you go. I know, I apologize. I can kind of just see that more, I think, just due to practice. But again, if any of you guys got to hear and understood everything, I'm happy out, because you're all morons. I'm kind of playing a game where when I pause it, I try to remember what I said last and see if I can join it together, even though it's been like 5 minutes and I can't remember what I said. I just remember telling myself to say, because you're all morons. Hopefully it's gonna be fun watching it back and seeing if they link up correctly or whether it's just completely wrong. Now, again, this one has nothing complicated in the sense of tans or arctans or cotans or whatever the fuck. But it's different again because there's no 2 fractions together to be added together. So we can't do the same thing that we've just been doing, which is fine. Now, you might be looking at this and thinking, I don't know how to do it. I think you can get away with it. Now, I'm going to do it in the funky pen, right? Because I wouldn't advise doing it this way. My way is mess around with the left-hand side until it turns into the right-hand side. And I'm not going to do it that way here. And I'm conscious of the fact that it's probably not the correct way of doing it, but I'm also conscious of the fact that you guys might not be able to see it. I'm going to do it the real way now as well in a second, but you guys might not be able to see it. So if you were stuck and if you had no idea what you would do, I would take both of them and just like don't mess around with the left-hand side, just use both of them. So what I would do is I would say, well, there's a cos x on the bottom here. If I want to get rid of the cos x here, I would multiply on both sides by cos x, because then that would cancel on this side. And then if I want to get rid of the 1 minus sine x on this side, I would multiply by 1 minus sine x on this side. Now, this is kind of like, to an actual mathematician, this would actually be kind of like a hint as to what you're supposed to do. But if in doubt, just try this, because then 1 minus sine x, 1 minus sine x cancel. 1 minus sine x by 1 plus cos x would be, I'm going to just skip it a bit if that's okay. You can do it out properly and get to here, hopefully. Here you'd get cos squared x, but according to page 13 of your log tables, 1 minus sine squared x is cos squared x. And that is true. So, if in doubt, try it that way. You know what I mean? If in doubt, just try any old shite. If you have time as well. Again, I think you'd be better served. The problem with these is, like, if you got like a quadratic, or you got complex numbers, or you got sequences and series, or you got statistics or probability, those are all kind of like very set out questions, as in you either remember how we've been doing them or you can give it a good shot, but they're never like just come up with shit yourself on the day. And that's why I don't like these ones. You could spend ages looking at this and just never actually cop what you're supposed to do. And it's not a sign of intelligence or something. It just means we haven't shown you enough, and we just don't think it's relevant to show you enough, which is, I stand by that. So give it a shot. But if you're like literally just like, I have no idea, just don't, only try that type of nonsense if you have time at the end. You know what I mean? Don't forgo doing the algebra question because you want to give this a shot. You know what I mean? Now I'm going to rub all this out so you guys can pause and rewind, so you're fine. You don't need all that, because I'm going to do it now. What is technically the correct, I don't want to say that even, because that way is fine for you guys, I think. But I'm going to mess around with the left-hand side and make it into the right-hand side. And I was deliberating on how to explain this to you. But what I'm going to do is I'm going to actually just say it this way. It's not really what you're supposed to do, but we have a cos x on the bottom, but we wanted a 1 minus sine x on the bottom. So what I'm going to do is I'm going to do the kind of shenanigans we were doing before, multiply on top and bottom of this fraction by 1 minus sine x. Because then we do have a 1 minus sine x on the bottom. We just also have a cos, and we're going to try to get rid of him now in a second. But I'm going to multiply out the top bit, and you get 1 minus sine x plus sine x minus sine x squared. And that's kind of what I was doing the last time when I told you I was going to skip a line or two because I didn't think it was hugely necessary for the bit I was going to do. I'm unhappy with that line. That one's still not fantastic, but I'm better with it. You'll notice on the top, the two signs cancelled, and that's how I got the 1 minus sine squared in the last one. Now you're left with 1 minus sine squared on the top. But if you remember on page, again, you guys can pause this at any point if I'm going too fast. I just know that there's not really much explaining here. I'm just kind of writing shit out. And I just feel like I need to fill the void with noise. 1 minus sine squared, as we know from the top right of page 13, has supplied us with the information to tell us that we can replace that with cos squared x over the cos x 1 minus sine x. But you notice cos squared is like cos by cos. So one of them will cancel with the cos on the bottom, and we'll just be left with a single cos x on top over 1 minus sine x on the bottom, which is what they wanted on the right hand side. And hey presto, we're donezo. So after saying I played a game where when I pause I try to remember what I said, but I don't think I just left out or left on a note at all. It was just kind of like I finished the sentence. So we're going to go straight into this one. This one, I didn't write out all the words, if that's okay, but it just said it wanted you to put the graph of this it wanted you to graph this out, fair attempt anyway, because it's not going to be perfect. But basically, this is the idea in trigonometry of graphing the sine and the cos graphs. Technically, tan is also there, but tan is a weird one, where tan constantly goes from minus infinity to plus infinity again and again and again and again. And as a result, it's not only is it more difficult, it's actually just more difficult to make questions for. Like, you can't test as much. So they rarely, I've never seen them ask it in an actual leaving cert, maybe a mock one time. But sine and cos are the two more important ones. They're always written, again, I have a video on this, look this up, I'm going to go too in depth into this and it's just going to slow things down. But they're always written as a plus b cos of cx or ct or c whatever the fuck, some letter. And the logic here is a is the middle line, so let's say that's the x-axis. Whatever a is the height that the middle of the sine or cos graph is like wrapped around. So that's a height of a. B tells you how far up and down you go from the a. So you'd minus the b from there and you'd plus the b. And that'll tell you the highest and lowest points the graph will go down to. And then the c follows the formula here that the period is equal to, now it's 2 pi over c, or 360 over c, depending on whether you're using degrees or you're using radians. Refresher, don't forget, period is how long it takes before the graph starts repeating itself. So basically, how far down the graph you'd have to like cut before you can copy and paste for the rest of eternity, right? Now I'm going to actually do it out here, and we're going to see this. You'll notice here, there's nothing in front of the cos, so that automatically implies a is 0 and b is 1. If you agree with me on that. So if I was to match it up with this one, you'll notice that I would immediately say a is 0, b is 1, c is 2. So that means the period would be 360 over 2 or 2 pi over 2, but either way it'd be 180, or if you were in radians, I suppose you would have 2 pi over 2 is pi. So that means that it repeats itself every 180 degrees or every pi. So if I was to do this out, now this is going to be an absolute mess on this because I have the ability to draw straight lines, which is fine. So I can do the axes in okay, but the curve line is going to be a nightmare for me. So specifically in this question as well, it asked for anytime it crosses over an axis to put in the actual coordinates of that as well. So if it crosses over the y-axis or the x-axis, put that in. One thing I haven't mentioned also, a sine graph always starts in the middle and then goes up. A cos graph will always start, I should just do a different color actually. A cos graph, no I shouldn't, I'll do it over here. I was going to do it on the same thing. Cos graph always starts at the top and goes down first, right? And then they do the wibbly wobbly bit. I'll point out if there were a minus sign or cos, you just do the inverse of it. So the minus sign would still start in the middle, but instead of going up first, it would go down first and then up and then down. You know what I mean? It's just the mirror image of it. And then a minus cos graph would end up at the bottom and go up first. So again, just the mirror image of it through the x-axis. You just do the reverse of it. I'm sorry I messed that up, but again, you can rewind and, you know, you're an adult, I suppose. If you're doing this, you should be close enough anyway. So A was 0, so that means the middle line, because don't forget A is the middle line. So for this guy here, where A was 0, it means we're going to start at the x-axis, right? Because that is when the height is 0. If it would have been a 5, I would have started up here instead. But because it was 0, we're starting at the middle, because that's where the height is 0. The 1 tells us how far up and down we're going to go. So it means we're going to go up 1 from 0. So that's 1 for anyone who doesn't know. We're going to go down from 0 1 space, which is minus 1. Again, for those of you who are curious. So then, because it's a cos graph, it's going to start at the top and go down. And the period is, I'll do it in radians, I suppose I should. The period is, oh no, they said in between 0 and 360. We're going to do it in degrees. So it says in between 0 and 360. 0 is on the x-axis, or the y-axis, so that's fine. 360 I'm just going to pop over here. Now normally they will kind of give you graphs nowadays. Well, yeah, they give you some format of the graph. I'll talk about that in a second. So the graphing bit isn't as big. It used to be bigger. You guys are shy at it because you can't do it, because you haven't done it. But I put 360 somewhere at the end, and I just said that looks like roughly halfway, so that would be 180. That looks like roughly halfway again, so that would be 90, and that looks roughly halfway, so that would be 270. Now the reason I put that in will be evident in a second, hopefully. So this is a cos graph. It should start at the top, which is at 1, so it's definitely going to start here, and then it's going to come down and up and down and up and down and up. But it has to repeat itself in 180 degrees. We found that to be the period up here when we did the 360 over the C, which is 2 in this scenario, just to highlight that, right? So the period is 180 when normally it's 360. So here it's 180. So that means the graph has to like fully come to us, not come to a stop, but go through one loop before this red line. So that means that the cos graph would have to, at this red line, I know I've ripped it out, but it would have to start at 1 again. It has to start at the top and go again, like as if this was the start again. Like it was all just starting again from scratch. So it had to start at the top and go down. So that means the graph has to go down and all the way back up and hit at this point. Again, I don't know if you can follow my cursor. I don't know if I have... There's a way of setting it up that you can miss that out. But basically, because it has to be at 1 here and 1 here, it has to be at minus 1 bang in the middle. So it has to come down to here. Now, don't just do like... Don't use a ruler, because that will make people cry. You have to make it look like a cos graph. I'm going to use dotted lines because I think it's easier for me than if I try to do a curve. It's just going to look atrocious, right? I'm saving you all trouble. So you'll notice that this looks not too bad. And there you go. That would be the cos graph between 0 and 180. Now, they asked us to do between 0 and 360, and I'll do that now in a second. But hopefully you can see how putting in the 3 kind of guide points kind of gave me an indicator of what I was going to do. In the same fashion here, because the period is 180, it should repeat itself in between here and here again, right? So that means over here, it would have to come back up to here, because that's where it would have to start on the next one. If I was to do a next one, I'm not going to. So that means it has to be in half, it has to be at the very bottom halfway in between those two then. So that means it'll be at minus 1 at 270. So then again, we just do the same nonsense again, kind of like this. I might have kind of, that looks a bit jarring to me now actually. I've scuffed it ever so slightly, but again, the graphs, they kind of, once it's I'm almost doing it too delicately. They kind of just want to see that you know what you're doing. Once you put in the right period, once you put in the right middle line, once you put in the right amplitude, which is how far up and down, that's the fancy name for it, you're kind of on the right track. They said, now in the question, they did say, show where, what did they say? Show where it crosses the axes, right? Isn't that what it said? The sketch must include coordinates of all the points where the graphs meet the coordinate axes. Yeah, I don't know if they'd actually ask that in the leaving cert like that, but we might as well do it, I suppose. You're not going to be too fond of it because it's basically caste system question again. So this was the function. They're asking us, when does that function hit the x-axis? The x-axis is a height of 0. The height is y. So basically what they're asking us, when they say when does the red line hit the x-axis, they're asking when can we put 0 in for the y. So we would, instead of writing y equals cos 2x, we put 0 is equal to cos 2x. But then it becomes a caste system question, and I do want to actually talk about one of these, so it's a good thing it came up. Actually, I forgot to mention it before. You'll notice here we got cos 2x is equal to 0. I'll do these equal 0 on the other side. I know that upsets people to write it there. I know you are all weird. Normally what we would do at this point in the caste system question is find out, and we recognize as a caste system because its cos or sine of an angle is equal to a number. Normally we pick the quadrants, but is 0 positive or negative? It's neither. So the way I like to think of it is we're going to go in all 4. It's technically probably not the correct, like an actual mathematician would tell you, like that's not what you're supposed to do, but it does work for the purpose of what you need it to work for. So what we would do is you get a reference angle and we do cos inverse of 0, which is 90, I think. Cos 0 of, yeah, sine inverse of 0 is 0, cos inverse of 0 is 90. I think that's correct. But what that means is in the 4 quadrants, we're going to go 90. And if we follow the 4 rules from, again, at the very start of the video, I'm not going to write them all out again. The first quadrant is just whatever the reference angle is, so one of them is 90. The second one was 180 minus 90, which is also 90. Then there's going to be 180 plus 90, which is 270. And then there's going to be a 360 minus 90, which is 270. Yeah, so you notice that our 2 angles that we're going to use are 90 and 270. So we do the same. Now, there's a bit of shenanigans there that we wouldn't normally have dealt with. I'm hoping you are okay with it. I can see why you wouldn't be. But I promise it is just the same as before, where you write 360n here and here. Divide everything by 2. Again, this isn't a type of question. I'm kind of not spending a lot of time on this because this isn't a type of question that they can ask similar ones, but not enough that I'm kind of like, oh, I'm going to go over this in this question. I might have done it in the trigonometry video, so if you want to check there and just be sure, yeah, maybe give that a shot. But something there looks wrong, because that wouldn't be. No, it's fine. No, it's fine. I'm doubting myself, but I shouldn't. So we just do n equals 0. Then we find out that x is equal to 45. X is equal to 135. That's like a combination of 1 and a 3. I can't lie to you. Now, those are the first 2 answers we're getting, 45 and 135. And you notice it does make sense that this would be 45 and this would be 135 because they're exactly in the middle of 0 and 90 and 90 and 180, which is fine. I just don't. People at the start might have been like, it looks like it, so I'm going to guess. But I never like when people do that because you guys guess some horse shit sometimes. It's crazy. If you sub in 1, you would get 225, and you would get 315. And those are 2 more answers, and you notice they are suitable for here and here. Now, you should write them in on the graph, but again, I'm not, no one's checking this. If you went 1 further and subbed in 2, though, you'd be having a problem because it would go over 360, because you would get 405, I think. But that's problematic because our graph only goes up to 360, so we don't want it. It's kind of like the same as before when we kind of said, oh, it's out of our bounds. But here's an actual physical manifestation of it, that it won't fit in the graph. I'm going to write out the other one now. Hopefully it's okay. Okay, give this one a shot then. We'll see how it goes. I'm happy with that, though. Same kind of question. You notice that instead of a plus b cos cx, we would say a is 1, b is 0, or b is 1, sorry, Jesus Christ. I've been doing this a long time now. I've just been sitting in one go. I've been pausing, don't you forget. Yeah, no, that was horrendous because that's a 1, that is not a 0. If there's no number in front of something, it's implied there's a 1 there. People always say 0, and I am horrified that I also said it now in case any of you take that as truth. But again, I'm going to draw out the graph. I should have done straight lines. Why didn't I do that? I'm going to do it the graph. They will give you a graph, probably, it's in between 0 and 360 again, so that's happy days for everyone involved. That looks okay. Now, A is the middle line, so this time we're actually going to start at a height of 1. B is 1, so that means we're going to go up 1, so we're going to go as high as 2, and we're going to go down 1, so we're going to go down as low as 0. So our entire graph is going to bounce in between 2 and 0 this time. That's what it means. Starting line plus or minus whatever B is will tell you the limits to it, the up and down, the range to it. C is a half. So if I put it into the formula for the period again, I would have 360 over C, which is 360 over a half, which is 720, which is horrific. Because they only wanted us to do it up until 360. So what I might do is I might like have a fake 720, if you get me, so I can kind of like show you what I'm doing. So it's a cost graph. Again, it's going to start at the top and come down and then go back up. Hold on, did they do this? Because they have it on the... Yeah, I think they also did it up to 720 as well to kind of highlight how to do it. Is that, I don't know, the graph is scuffed. I take it down right? A half X, yeah. Okay. I just wasn't really expecting it. But if you think about it, the period of 720, which 360 divided by half is, that means that it has to start here. It has to go through 1, down and up to the start again. It has to reach the starting point again, is what I should say, after 720. So like here-ish. So in the middle of it, it has to dip down to the very bottom, but don't forget the very bottom this time is 0. So that means it has to dip down to here, because that is the very bottom that it can go down to, which is 0, halfway between the start and the end. And that's what a cost graph looks like. Cost graph, don't forget, looks like that. Each time it repeats itself. You know what I mean? It's like a weird U shape that you put on each time. So weirdly, this is going to look absolutely horrendous, where it's going to be like something like this shit, where it's going to hit the bottom and then bounce back up to here. Right? Now, the bit on the right is a bit kind of just so I could fit it into my computer screen, but they don't really care about any of that. They only asked in between 0 and 360, so that literally doesn't matter. So that's what this graph kind of looks like. A lot easier to do, because they asked when does it hit the axes, but it doesn't really hit the axes other than the points we've already kind of established of 2 and 360, you know what I mean? So I would be comfortable enough just kind of saying that. I'm going to get rid of the squiggles though, because I don't like it. Okay, I'm going to leave that there then. Again, I think I've done a video on this, so if there's actual problems, go look there. I'm going to get too involved otherwise. Okay, don't laugh. I tried to draw in the graph that they had. Hopefully it's decent enough that we'll be able to answer the questions. You can see it yourself though. If I gave you this question already, you can kind of see the graph, and hopefully it kind of matches up enough. Yeah, we can still do it. But this is one that they will ask in reverse of the previous one, where before they gave us the maths and we're kind of like, what would the graph look like? Here they're giving us the graph and being like, yo, what would the maths look like? So they're saying, write this out in the form of y equals. Now they use capitals. I hate that, so I'm not going to do that. Nothing wrong with it, I suppose. I just don't like it. Do this where x is in degrees and a, b, and c are constants. But again, that's just kind of like what we were doing. What is the period of the graph? Well, the period is how long it has to go before it repeats itself. And you'll notice that a big problem here is people kind of go, oh, well, in the costs, it was, if it started here, it had to come back to here after like a period, right? So we would say that's one period, right? Problem is, for sine graphs, people go, oh, well, that means that here, as long as it comes back to this height again here, oh, this is the period here, right? But that's not correct, because it doesn't repeat like that. You know what I mean? The period is how long it goes before it repeats itself. So you notice the period for a sine graph like this is actually from here, not to here, but to here. Because then it would be your boy like this. And then if you repeat that again, you'll notice you get this shape again. And then you'll notice you get this shape again. You know what I mean? So it's the same kind of thing. So the period here is, I'll get rid of all those green things, but the period here is actually 120, I believe, if I did the graph the same as what they have. Yeah, because it takes 120 degrees before you get back to, you could literally, up until 120 degrees, you could cut that part out, cut it from here to here, and just copy and paste it all the way for ad infinitum, like just keep going. So I would say period is equal to 120. Now, in the question it says, what are A, B, and C as a result? I'll use the period because we have it here, but if you follow the formula of the period is equal to 360 over C, that means instead of period equals 360 over C, it must be 120 is equal to 360 over C, because 120 was the period. It's just kind of filling into the formula like we were doing in the past ones, but instead of subbing in for C, we're subbing in for the period. If you do maths shenanigans there, you multiply on both sides by C, divide both sides by, if you multiply on both sides by C, I'll do it out the long way. You get 120C is equal to 360. Divide both sides by 120, you get 360 over 120. Which is 3, by the way. I didn't really highlight that. So C is 3. We know what C is. A is the middle line, and you'll notice that that is here. So A is 1. Now, I know I missed it on my graph, but A is going to be the 1 because it's where the sine graph kind of centers around. So A is 1, and B is how far up or down from A you went. We went up as high as 3, we went down as far as -1. So that means B is 2. Now you do want to make sure that, as I said, sine always starts in the middle and goes up. And because this one does, that means we know it's a positive. If the graph had been again like this, it would have just been minus in front of the B sign. But it's not, so it's chill. So y is equal to 1 plus 2 sine 3x, sorry, my apologies. And that's the answer. Hopefully you can put it in the graphing app to check it out, but you know, you won't. Okay, so this question is not one that I've ever seen on a leaving cert before. I'm still gonna do it, but I've never seen it. So when I saw it at the start, I was kind of like, oh, what the fuck? And then when I thought about it, it's doable. It's just you're not gonna be like, I know one of you in particular has actually like kicked up a fuss about this in the past, but the idea is here they gave us a graph. They told us that it's y equals a cos x plus 60. Hang on now, if that's going to be 360, that's going to be 180. It's going to be move it to -6. Oh yeah, okay, yeah, no, I can see that. So cos graph, we know normally starts at the top and then comes down like this, right? And then the period would stop there and we'd go again, and the period would go again. So that's normally what a cos graph looks like, and it would go like this into the minus side if you're okay. So it would go like that roughly, and then the x-axis would kind of stretch out somewhere there. I know it's shite, don't judge me, but the problem is it's the x plus 60. Normally it's a cx, and we just know that the period is just divided by whatever c is. The plus 60 bit throws the graph. Now the thing is, if you just put a +3 at the end of any function, if you just did the function that you started with and just add 3 to the end, you're moving the graph up 3 spaces. Everywhere the original fx graph was, you just literally slide it up 3 spaces using translation. However, because the plus 60 is in with the x inside of the maths that we're having to do, so if it was cos of x plus 60, or if it was x plus 60 squared, or if it square root of x plus 6, I was going to say, but that's, I wouldn't worry about that one as much. That's going to be more complicated. The idea is, though, if it's in with the x inside of the maths, if you follow me when I say that, you move the graph left and right as opposed to up and down. So if you tape it on the end, it would just be move it up 3 or move it down 3 or move it up 17 or whatever you do. If you put it in with the x, you have to move it left and right, but you move it the opposite way that you would think. So the plus 60 is not going to move at 60 this way. It's going to move at 60 the other way, if I have that right. When I do this out, I might realize I'm wrong, but I'm pretty sure I remember this. I'm just not used to doing it with cos. But yeah, it should be that basically now, instead of remember we said the cos will always start at the top on the x-axis, the y-axis, sorry. we're kind of tricking the graph into starting at minus 60 on the x-axis instead. So if you go to minus 60 and have your x-axis here like before, that's not going to turn into a straight line at any point. The cost graph won't start at the top here. It'll start at the top here at minus 60 and then go down kind of like what we have been doing. And you notice that's kind of what's happened with our graph, because the bit at the y-axis is very clearly not at the top level because the graph goes much higher than that over here. So it's not that the cost actually starts here, it's that it starts at minus 60 somewhere. I should just do it on this graph, I don't know. So really it's that it like goes back over to here and then like peaks there. That's like the top of the mountain up there, and it's going to be like at minus 60 here. Now why does it do that? I'll say it once, but you're not going to be happy about it. You're not going to get it. It doesn't click for a while when you do it, so I don't hold out much faith, but I don't actually care either because it's not that important. But the idea is you're kind of tricking the graph into thinking to start at minus 60 because everyone says, oh, if you put in plus 60, you should move to the right 60. But what you're doing is you're tricking the cost graph into thinking it's beginning when x is minus 60. Because if you sub in minus 60 where you see an x there, in the cost bracket, what's actually you're telling the cost to do, even though you're telling the cost, oh, we're at minus 60, the cost bracket, the cost thinks we're actually doing costs of 0, which is what we normally would have done here. So the cost is reacting like that, but over the minus 60 instead, because we've said the plus 60 kind of, we had to put in the minus 60 to counteract the plus 60, and then the cost graph thinks we're starting because it would get 0 at minus 60 and it would just run like normal, like a normal cost graph would. Wouldn't worry about it too much. Just know I'm going to leave this here even though it's jank as balls, but I think it might be handy for us later on. I don't know. If you have plus 60 inside of the mats, you move to the left. If you had minus 60, we'd move to the right. If it was just this plus 60 at the end, then we just move the graph up 60 spaces. There's no left and right nonsense. But it's not just at the end, it's in the middle of the mats. Like, it's really important. It's like right in nested in the center. So I can completely understand none of you would have gotten this. I can't imagine. You can put it in the graphing app just to be sure, just to know that I'm right, because again, this isn't something I'm as confident doing. Just I'm like 99% sure, but it's just because I haven't done one before, so I haven't. I'm just kind of flying off the seat of my own arse here. Now it asked for what A was the first question. It said what was A. Now how would we do this? Well, because it's cost of x plus 60, I'm assuming, and I think I'm safe to assume this, that the period is still the same as just cos x. The period width changes with the number in front of the x, and if there's no number in front of the x, the period is 360 degrees. So if it's 360 degrees, that means, let me just think, how am I gonna so if it's 360 degrees, what I mean is if this is minus 60, over here after it periods, if you get what I'm saying, which I know you're all gonna giggle about, you grow up, you're like old enough to drive at this point, right? So let's chill out the word period. So the period would exist at 300 instead of at 360. So normally it would exist between 0 and 360, but because we were pushed back to minus 60, it's going to start at minus 60 and then push up to 300 instead. It's still an iteration of 360 degrees. That means that it must have hit the bottom at it must have hit here at 120, because it's halfway, like 360 is the full thing, so 180 is halfway. If you go 180 down from 300, you get 120. If you go 180 up from minus 60, you also get 120. Did I say something wrong there? I might have done. It's 180 away from both minus 60 and 300. It's halfway in between minus 60 and 300. That's a much better way of saying it. I'm flustered though, so don't judge me. Now, the logic that I'm assuming they're going with is that the only number they told us about height-wise is where it crosses the y-axis at a height of 2. And they're saying, I think they say that A is 4. Isn't that what they say? Is that right though? Because oh yeah, I'm being stupid. We're just gonna math this out. I was trying to like eyeball it. Not a chance of we doing that. All of this is important, I suppose, to explain to you what the 60 is, but now we're actually going to do the maths for it. I just copped. What we're going to do is we're going to take the point, and if it's a point, we should be able to sub it in, and it should make sense into the function. I was being like super slow there. Just know I've been sitting doing maths. I know I've paused at certain points and it's not going to be as long, but like I've been sitting here this whole time. That's my excuse. Deal with it. The y is 2, the x is 0. So that means up here the y is 2, a is a, cos is cos, the x is 0 as I said, and the 60 is 60. So you end up with 2 is equal to a times cos of 60, which is a is equal to, or sorry, 2 is equal to a times a half. And instead of multiplying by a half here, you can divide by a half on this side. 2 divided by a half is equal to a. That means 4 is equal to a. So that is true. It's just not how I would have imagined it. But I suppose a cos and a sine graph don't really go in. That's why earlier, do you remember when I was saying that in the other one I didn't want you to kind of guess that it's halfway between 0 and 90, so therefore it's 45, because the sine and cos graphs they don't dip. It's not like a diagonal line straight from here to here. You know what I mean? It's not perfect like that. It kind of rounds like that. So I was just kind of afraid. I can understand why it works halfway now, but I can also see that you can see yourself here that it doesn't work. Well, yeah, I don't know. It just kind of is weird. I suppose it's a cos. I'll put it in the graph and afterwards. Just make sure everything I'm doing is legitimate. If I've put this up, just assume I'm fairly confident with it, to the extent that you guys are going to be okay with it. But a is definitely 4. The maths is true. So we can change that to y is equal to 4 cos x plus 60. Now it does ask then what are q, r, and s. And I didn't out the whole graph and explain it all because I thought we were just going to have to like eyeball it and figure it out from like placing like I was trying to do before. But because we know what a is now, it's the same as before. They're asking us where does it cut the x-axis. At the x-axis the y value is 0. So they're asking us, do you take this graph, but instead of writing y, write 0? Because on the x-axis that's what the y is. And they asked us what is it the dealio with the x-axis. So that's what we're going to do. If you recall though, it looks like sine, cos, or tan is equal to a number, but we don't want the 4 in front, so we're going to divide both sides by 4. But, yeah, so it makes no difference. The 4 made no difference at all. Because you divide both sides by 4, 0 divided by 4 is 0. Happy days. Oh, look, cast. Amazing. Now, again, this might not be, all students take care, this might not be the most official way, but because it's equal to 0, and you can write it on this side, don't cry. I'm going to do all 4 quadrants. I'm going to get cos inverse of 0 again, which we already know is going to be 90. Yes, yep. So that means that we're going to go into all 4 quadrants again, but you notice again, if we do the same thing, we get 90, 90, 270, and 270. If we use the 4 rules from the very start that I did at the top left, I think it was. So then we're going to have, now here's the difference though, it's going to be x plus 60 is equal to 90 plus 360n. And x plus 60 is equal to 270 plus 360n. If we're just doing cast system questions again, that's all this is. You bring the 60 over and make it a minus, so we get x is equal to 30 plus 360n. If you have any questions on any of this, just text me. You know yourself that you can just be like, yo, what did you mean by this shit? And I might go, oh yeah, I didn't explain that properly. Or I might go, you're an arsehole for not knowing that straight away. But like, you're just going to have to live with that. And then we're just going to do n equals 0. And that means that the first x is 30. Second x is 210. Those look suitable, right? Q looks like it would be 30. This looks like it would be 210 just because it's in between 120 and 300. I can respect it. And it's again halfway between. It's 90 in between, which yeah makes sense. I just don't trust it. N equals 1. Whoops, my brain, whoops. That would be x is equal to 390, which yeah, we've never really been dealing with outside of 360, but yeah, that's fine, that makes sense. Now I could do it once more, but there's no real need to do so. It would be 570, but the graph goes nowhere near that. It's miles down here somewhere, so I'm not going to bother too much with that. So those are your three answers: 30, 210, and 390. Now, if they wanted the actual coordinates, I can't remember what the words were, but if they wanted the actual coordinates, you'd obviously have to write them as like Q would be the point 30 comma 0, because it's at 30 on the x-axis and a height is 0 on the y-axis. Or would be 210, 0, S would be 390 and 0 for the same reasoning, because it's on the x-axis. So therefore it wouldn't have a y height, it wouldn't have a height to it. What is next? I forgot to pause it. Fuck you. Again, so this question isn't exactly how it would be on a leave insert ever either. But that has been, up until now. There's a big problem with these types of questions that your calculators are getting so advanced at these questions. They used to ask, what is tan of 75? And there was no way of us to figure that out unless we did the maths out exactly as they wanted. You nerds will just be like, oh, I just put in my calculator and it just tell me. You're class, you're amazing, your calculator does square roots, we're all impressed. But the idea is that they're trying to, I've seen it the past couple of years, they're trying to change this question around in a way that your calculator just won't be able to do it. Like one year they said, figure out what tan of 75 is, give your answer in this form, and the form they asked for was like the second last step that we would do in the maths, because they knew that isn't what the calculator would give. The calculator would give the last step, and that just threw people, and I found that funny on my end, I'm going to be honest with you. So this question isn't one that we would have seen necessarily written like this in the Leaving Cert, but it's similar to it, and it might actually be good practice because of how they're trying to change this. It might be kind of how they go with this question. It might be, I could see this, maybe not. But it's in the right realm, right? So the idea is, in the question, I didn't write all the words, but they say, by expanding tan of theta plus 45 with the suitable value for theta, show clearly. I'm not going to deal with the second part. I never advise you guys to look at the second part until we're finished with the first part, because sometimes it can just be too, if you try read it all at once, you end up trying to do like both of the questions at the same time, and it just doesn't work out. It's too taxing on your little brains, right? So tan of 45, they do theta plus 45, but basically it's tan of thing number 1 plus thing number 2, right? But instead of thing number 1 and thing number 2, I'm going to do A and B, because I know for a fact that's how they do it in the log tables. On page 14, you notice that they have tan A plus B here is equal to this shit. So what you would do is you would say, oh, well, if tan A plus B is this guy and tan A plus C is this guy, that means I can rewrite it as tan. Now I'm making it kind of a mess here because of the layout of my page, but you guys can be a bit cleaner with it. So it would be this. The only thing is, what I'm going to have to do is obviously change the A's and the B's around, because of what they gave me in the question isn't A and B. So in the red, then I'm going to do, so like, you know what I mean? I'm going to match these two, and then I'm going to match these two. I just haven't done the second bit yet. But if we replace A and B with theta and 45, we'd end up with tan of theta plus tan of 45 is in the B position, because it just matches up here and here. Again, I don't know if you can see the cursor, and I'm just waving at nothing then. But these two match in this kind of situation, this kind of manner. So we'd end up with this down here. Oh yeah. Okay, sorry. People keep texting me. I keep getting sidetracked. One of them was just one of my mates insulting me about football. So, sorry to, But we fill this in. Fill in for theta, we fill in for 45. This is what we get. So tan of theta plus 45 can be rewritten as this, and that is the answer to the first half of the question, where they said by expanding tan of theta plus 45. That's that. Now the problem is, they said, now by picking a suitable value of theta, show that tan of 75. What would we have to put in for theta in order for theta plus 45 to be 75? It must be 30 goes in place of the theta, right? Because then we'd have tan of 30 plus 45, which would be equal to tan of 75. But tan of 75, the whole reason what they were trying to do is, beforehand, before the calculators were this good, that you'd have to go to the log tables, and the log tables have 30, 45, 60, and 90, and the 180 and 270 and 360. But they don't have 75. They don't have anything like that's just like a random number. So they just threw this in like so. But basically, instead of writing tan of 30 plus 45, I'm just going to kind of, in the same way this turns into this formula, I'm going to like make my own formula down here. But basically, everywhere instead of 30 or theta now, I'm going to put 30. That's all. So instead I would have tan of, instead of theta, it's going to be tan of 30. It's still plus tan 45. Because for some reason they put the 45 in and then asked what theta would have to be. I can understand that actually, just to make sure you didn't pick random numbers. You didn't pick like 15 and 60, which would have just been a nightmare. Instead of 1 minus tan theta on the bottom, it's going to be 1 minus tan 30, tan 45 on the bottom. Now, the thing is, in your log tables, now I'll just highlight, I should have just pointed this out to you. The whole thing was, back in the day, you would have had to use this kind of grid here, where we would have said, oh, tan of 30. I'm really sorry, I don't know if we have the thing on. So tan means this kind of row down here. So you'd look at that row and you'd say tan of 30. 30 is this column here. And you'd say, well, they line up here. So that's 1 over root 3. If you guys put that into your calculator, it won't say 1 over root 3. It'll say root 3 over 3, because your calculator is designed not to have roots on the bottom. And it's the same thing. It does not matter. It's okay. It'll work out either way. Yeah, it's just going to be messy. Tan of 45, again, you do the same logic and you come to 1. You'd say 1 minus 1 over root 3 then, instead of the tan 30. Multiply it by tan of 45, which is 1. Now, again, you guys would just put this all in your calculator. And I think it's safe to say at this point you'd be like, look, you know, the maths is all there. What we would have to do is we'd have to recognize this is 1 over 1. Change that to 1 over 3 is still 1 over root 3, but change this to root 3 over root 3, like with my earlier trick of we can multiply the top and the bottom of this by root 3, and it's still the same fraction, it just looks different. Then here we'd end up with 1 minus 1 over root 3. Then on the top, we'd end up with 1 plus root 3 over root 3 if we combine these two fractions together. Then we put it over 1 minus. Now, actually, I should have done it under here as well. I should have changed this into 1 over 1. Because then this would change into root 3 over root 3 minus 1 over root 3. Then I'm going to do it down here if that's okay. The 1 plus root 3 over 3 on the top is still fine. The top half of the big fraction, he's just the same. On the bottom, though, we can unite these two fractions and get root 3 minus 1 over root 3. But instead of dividing by a fraction, instead we can end up multiplying by the fraction inverted. So the top half of the big fraction is still chilling. But instead, we're going to multiply it by root, you know, this guy upside down. Root 3 is on the top instead of on the bottom. Root 3 minus 1 is on the bottom instead of on the top. If you do top by top, bottom by bottom, you'll end up getting root 3 plus 3, because don't forget, root 3 by root 3 is root 3 squared, and the root and the squared cancel, and you're left with 3. On the bottom, it's the same thing. You'd end up with 3 minus 1. Showed as 2 plus root 3. I don't know if I've done this right. Is this right? Have I goofed somewhere? Minus. Yeah, this is minus root 3. That's where I goofed. I think I see this, but I don't know if you are gonna be fond of it. But either way, you guys will do it on the calculator. That's kind of a cop because I can't see it at the minute, and I'm kind of like, I'd have to pause it and I could figure it out eventually. I just don't know if I want to. I don't know, because there's still another question. I suppose I'll pause it for a second and I'll see if I can figure it out. Hang on. Yeah, okay. So basically, I promise I wasn't that long. But basically, before multiplying this out, what I could have done is I could have actually just seen that the root 3's here cancel. It's still not perfect because we'd end up with 1 plus root 3 over root 3 minus 1. But if now we kind of only really do this in complex numbers, it is technically a part of surds, but if you multiply the denominator by the conjugate, or if you multiply the top and the bottom by the conjugate of the bottom, the square roots should all cancel out on the bottom. If I multiply that out real quick, what would I get? I don't know how important this is to you. I don't know if you guys care about this. You'd end up with, but I'm going to do it out. Root 3 minus 1 plus 3 minus root 3. The root 3's cancel. Because I didn't do... Oh my god, Jesus. Ignore this for a second. It's supposed to be the conjugate of the bottom, and I just did not do that. I did the conjugate of the top. My apologies. If you multiply by the conjugate of the denominator, hopefully you're okay with that. I guess I'm just more tired than I expected, or retarded. I don't know, one of the two. If you do that, you get 3 plus root 3 minus root 3 minus 1. But then the root 3's would cancel down here, which is what I was intending to do the first time. You'd end up with, yeah, okay, I thought I'd done something else wrong, but I see it now. 4 plus 2 root 3 over 2, which is 2 plus root 3. Happy days, Jesus Christ. Okay, so the very last one, I haven't written it out yet, so screw you guys. But the very last one is more so how it would be written in the leaving cert, at least before current times. They said show that sin of 15 is equal to root 6 minus root 2 over 4. Now they said using compound angle identities, which is, if you recall, this section here. It's the name they give it here. Basically, this is more so the idea of what they would have done in the leaving cert, where the idea is sine of 15 again isn't in our grid up here, because we have 30, we have 45, and we have 60 on the top left there. So what we would have had to have done is we would have had to pick one that we could use. We could use 30, 45, and 60 and make 15 out of it. So for example, what I'm going to say is, well, it's sine first off, so we're going to look at the middle two. I know I've kind of covered all of them, but we're going to cover, we're going to look at like the middle two here. And what we're going to say is, we're going to use the a minus b, because if we did a plus b, we'd have to find two numbers that add up to 15, and out of these, we don't have candidates that can do that. However, we have multiple candidates that could do minus, and it would work. So what I'm going to do is I'm going to write out the formula here, just so I can stop being afraid you guys can't see what I'm pointing at. Sine of a minus b is equal to sine a cos b minus cos a sine b. So yeah, there's multiple candidates, because what we can do is we can pick, for example, sine of 60 minus 45. And then fill that in. You could also hypothetically do sine of 45 minus 30. You know, either of those works. I said multiple, it is just two, but like, you know, you live with your mistakes, I suppose. Sine of 60 cos of 45 minus cos of 60 sine of 45. Now if we were to do it with that one, what I would do is I go to my grid again, and I'd say, oh, sine of 60, that lines up with root 3 over 2. So what we would do is, now I'm going to like kind of box him off for a second, because I don't want him to confuse the issue. We would say, this is me continuing on the sine, like this is this, I'm not doing this, the red line separates it, okay? Sine of 60 would be root 3 over 2. So that's him sorted. The cos of 45 would be 1 over root 2. Minus cos of 60 would be a half, obviously. And then sine of 45 would be 1 over root 2 again. Now, if you're multiplying fractions, it's top by top, bottom by bottom. Do not get that wrong, or I'll be sad. Then we get 1 over 2. Now, we want these to both be over 4. It might be different. I'm hoping you guys just don't use a calculator, because your calculator will do it all sorts of different. We want them both to be over 4. This one is over 4, that's fine, so it matches up with what we have in the question. That's chill. This guy is a problem. What would we have to multiply that by to make 4? I know it's root 2, but if you guys want to be sure, what you can do is, what we're really saying is 4 is 2 root 2 multiplied by what, right? So it's like this, effectively. If you want to do that, you can just use your normal maths to get x on its own and say, well, if I do 4 divided by root 2, I'll figure out what x is. And if you do that, you should get root 2 is equal to x, right? So we know that if you want to make the denominator of the second fraction into a 4, you would have to multiply it by root 2. That's a tricky thing. I get that. By all means, text me and ask me if you have an issue with that. But what I mean is, I know that we're going to multiply the top and the bottom of this fraction by root 2, because then it would turn into my root 3 over 4 minus root 2 over 4. I realize, of course, they have a root 6. Did I screw something up? Sine of 60 was just root 3, was it? No, sine of 60 is root 3 over 2. Cos of 45 is 1 over root 2. Oh, that's what 2 root 2 as well. Sorry, I didn't even see that. Okay, how do I fix that? Sorry, my whole thing was I assumed this was a 4 originally, but it was actually 2 root 2. I just completely ignored this root 2. Sorry, I understand that can be confusing. The two denominator, when I multiplied these two fractions together originally, 1 by root 3 on top is root 3, and then I just did not see that square root, and I just did 2 by 2 is 4, but it is 2 root 2. So if we want to make it a 4 as well, we would also have to multiply it by root 2. On top and bottom. Root 2 by root 3 on your calculator, you can do it to be sure, but it is root 6, I can guarantee you that. And then on the bottom, I guarantee you it will also be a 4, but then you can unite them as one fraction because they have a common denominator, and you have this. I know I goofed that ever so slightly, but that's just numerical nonsense. You see how it works, right? I promise you the same would work for the 45 minus 30 if we had done it that way instead. But I won't do that because I don't know how long this video is and I don't want to confuse you. Hopefully that's okay. I think that's all of them. Hopefully it's not too bad. Hopefully you understand what's going on. Again, if you don't know, text me. A lot of this isn't hugely necessary for the actual leaving cert. And I do have a video on trigonometry as well that you can use. Good luck and God bless.